Okay, I'm back, and now we want to compare the relative sizes of the different objects in our solar system. So starting off with Mercury, you can see that Mercury is much smaller than what the Earth is. Mercury is a little bit bigger than our moon, but not by much. And you can see that Venus is about the same size as the Earth, and so it's been referred to as Earth's twin, but believe me, it's not a very nice twin. And then next to the Earth, you can see Mars, and look at how small Mars is compared to the Earth. So it's only about half the diameter, and that's going to play a very, very important role in determining the fate of Mars. So we're going to be able to explain why Mars looks the way it does, and its atmosphere and its plate tectonics. We'll be able to discuss all of that, and it's going to be basically based on its size. Then outside the orbit of Mars, you're going to have the asteroid belt, in between the orbit of Mars and Jupiter. And you can see some of the objects that are located in the asteroid belt, and you can see they're very, very small. Then you can see the moons of Jupiter, and you can see the moons of Saturn, and then the moons of Uranus, and then the moons of Neptune. And then that very last column shows some of the other objects that are outside the orbit of Neptune. And Pluto is the very first one, but do you notice that there are some objects out there that are even possibly larger than Pluto? So it's maybe a good thing that Pluto is considered a dwarf planet, and then you don't have to worry about it, because imagine having to memorize all of those other objects there. Now you might be wondering, well, why didn't they put Jupiter and Saturn and Uranus and Neptune on that picture? Well, they did, because if you look at that very first red line there, that is the outline of Jupiter. And then the one that's next to it, that would be the outline of the planet Saturn. And then the one next to it's the outline of Uranus, and then the ones next to it is going to be Neptune. So they're so big that they won't even fit on the picture. Now where's the sun? Okay, go all the way over to the right, and you'll see another red line, and that red line is the outline of the sun. And if you look at that thing, you might be saying, well, that's a straight line. Well, it's not. It's actually curving, and so that gives you an idea for how much bigger the sun is in comparison. So if the sun is 1.5 meters in diameter, so that's going to be about 4.5 feet. So imagine that's about the width of your arms, so about 4.5 feet. Then the Earth, in comparison, is going to be about the size of a marble. So that gives you an idea how big the sun is. Well, I couldn't help myself, so we always need to do math in here. And so I decided to make a scale model of the universe. And that is if, assuming that the sun was 4.5 feet in diameter, then we can figure out the diameter of any other planet in our solar system by using a proportion. And so let me show you how it works here. That a proportion says that A is to B as C is to D. So that what we could do is, I assumed that the diameter of the sun was 1.5 meters. So let's say that I know what the scaled down size of the sun is. Okay, then what I'm going to do is I'm going to divide that by the real diameter of the sun. So I will just symbolize that by D for diameter, and then I'll put subscript real. So I went to the internet and I found out what the real diameter of the sun was. Okay, then over here, let's say that I'm interested in knowing how big would the Earth be if it was scaled down. Okay, so that's going to be, let's say, X. And then I looked up on the internet what the diameter, the real diameter of the Earth was. So this was the real diameter of the sun. And then I looked up on the internet and I found out what the real diameter of the Earth is. And then I solved that for the letter X, and lo and behold, it turned out to be about the size of a marble. So it turned out to be, I'm trying to find Earth there, 28 millimeters, or 2.8 centimeters, or about the size of a marble. And then I did it for all the rest of them by using a spreadsheet, and those were the numbers that I got. So if we were talking about Jupiter, it turns out to be about the size of a basketball compared to the size of the Earth. And then I also calculated how far away it would be. So this scale model is centered on Ozarks Technical Community College in beautiful Springfield, Missouri. And so I said that the sun was located on our campus, and then the rest of the planets orbit around OTC the way they should. But where would then be the location of the Earth in comparison to that? And it turns out that there's a street here in Springfield called National Street, and then College, and you can see the distance there, how far away in meters that it would be. And it turns out to be 325 meters away from this 1.5 meter sized ball. And so I went ahead and calculated all those distances, and it turns out that we could fit the entire solar system onto a map of Springfield, Missouri. And then Pluto, you can see, would be way outside, almost on the limit of Springfield, out by what we call Lake Springfield. Okay, in our next segment, we are going to talk about a false explanation for the origin of the solar system. Be back in a moment.